Okay, so those are the reciprocal identities. Are you guys okay with that?
Yeah.
Okay. Yeah, and then there's the ratio. So just in general, you know, sine, cos, and tan, they're just ratios in a triangle. So if you have a triangle, and obviously right angle triangles, so this is my right angle, and I just choose this angle theta, everything is relative. So everything, all my sides are now relative to this angle. So this is the hypotenuse because it's opposite to the right angle. This is my opposite side, and this is my adjacent side. And we know sine, cos, and tan are they're just all relative angles. Sorry, relative sides. So sine theta, so you know sine is opposite on hypotenuse, so it's O on H. Cos is adjacent on hypotenuse, so it's A on H. And tan is opposite on adjacent. So when you think about sine, cos, or tan, anything to do with trig always comes from a triangle. The reason trigonometry exists is because triangles exist. And they're just ratios, okay? So they're not like so I think people just overthink trig, it's just a ratio. So if you just sort of keep this in the back of your mind, hopefully it won't be too confusing. So tan is a ratio of sine on cos, because you see tan here is O on H. So if I do sine, which is O on H, over A on H, I basically get O on A, which is why tan is the ratio of sine over cos. And we know cot is the reciprocal of tan. So cot would just be the reciprocal of this, which is just the flipping of that, which is cos on sine. Does that make sense so far?
Yeah.
Cool. And then to the next one. So the Pythagorean identities and the complementary identities. So Pythag obviously comes from a triangle, right angle triangle, and he relates the sides. So he states that h squared equals a squared plus o squared. And then when you move on to these identities here, they just derive basically from this, which is also like the equation of a circle. So if you think about the equation of a circle, let's just say this is a unit circle. So it's got a radius of 1. And it's got an equation x squared plus y squared equals 1, which is literally this. You know, a squared plus o squared is like x squared and y squared, and 1 is your h. So 1 squared is just 1. And everything else just comes from this identity. So, so when we look at our x, so I can call either side x. So I'm just going to call maybe ox. I did it in purple. So I can rewrite O as x, and I can rewrite A as y, just so I can give them different variables, and you can see how it's related to this equation here. So if I call this x and I call my angle here theta, then let's just say sine of theta, actually I did this over here. Sine of theta equals what when looking at this triangle?
Opposite over hypotenuse.
Yep, opposite over hypotenuse. And O is represented by x, right?
Okay.
And H is represented by 1 because it's a unit circle. Therefore, x equals sine theta. And let's do one for cos as well. So cos theta equals
adjacent over hypotenuse.
Yep. And adjacent is represented by the letter y.
Y over 1.
Yep. So y equals cos theta. Okay, so just off this, we can substitute these values of x and y into your equation here. So x equals sine theta is coming here, and y equals cos theta is coming here. So I get sine theta all squared plus cos theta all squared equals 1. I just expand that, and I get sine squared theta plus cos squared theta equals 1. And that's the first identity there. So does that, that one make sense? Yep.
Wait, can you start again? Just from the sine squared theta.
From like here, this line here?
Yeah, from there, yeah.
So let me just go back. So do you understand x and y over here?
Yeah, I get that.
Yeah.
But then how do you put them together to get the first identity?
Yeah, so here x, so I'm just now replacing like substituting values. So if x equals sine theta, then I can replace this x here
With sine theta. Okay.
And then I can replace the y with cos theta, just the same way. And the reason I can like substitute these values into the unit circle equation is because these actually come from the unit circle. You know, they come from the triangle constructed from the unit circle. Yeah. So does everyone know what a unit circle is?
Yeah.
So a unit circle, it's just a circle, but what makes a unit circle so exciting is the fact that the radius is just 1. So a unit circle has an equation, or I wrote it here, but the unit circle has an equation x squared plus y squared equals 1. So that's called the unit circle. So a circle in general has, or the general equation for a circle is x squared plus y squared equals r squared. But the unit circle is when the radius is 1. So in all these trig identities, we're always using the unit circle because it just means the radius is 1, and it can get us these identities.
Is it is the radius always 1?
Yeah, because that's the definition of a unit circle. So then these expand to give me that. So yeah, that's the first identity there. Now the remaining 2 basically come from this one, right? So I'm just gonna like highlight this. So if you know this one, you know everything else. So I'll just show you how you can derive the other ones. Do it in green. So from this, I can then just choose to divide each term by sine squared theta, right? So I'm just going to write it again here. So sine squared theta plus cos squared theta equals 1. I just choose to divide each term by sine squared theta just because I can. So I divide this by sine squared theta, I get 1. I divide this by sine squared theta. Do you know what I get?
Because of the sign, I don't know what it equals.
I'll put it like this. Yeah, I'll put it like this, and then you guys can figure it out. And then 1 divided by sine squared theta. So 1 can't be simplified, so I'll leave it as 1. So what's cos over sine?
Cot?
Is that cot?
Yeah, that's cot. And because they're both squared, it becomes
It's just cot squared theta.
Cot squared theta. And what's 1 over sine?
Sec.
Cosec.
Yeah, cosec.
Yeah.
Cosec.
So that's.
But is it squared?
Yeah, because sine is squared. So that's cosec squared theta. So if you recall, we've got 1 plus cot squared theta equals cosec squared theta. We go up to identity, and that's the one here. So cot squared theta plus 1. I'll rewrite it in the way that they have it. So it's cot squared theta plus 1 equals cosec squared theta. So that's the second one. And then who can guess how to derive the third one? So we'll derive the third one from the sine squared one. Do you know how we can derive that one?
You divide by cos squared theta.
Yeah, exactly. So I'll do that in red. So I'm going to rewrite the first one again. So sine squared theta plus cos squared theta equals 1. So this time I divide by cos squared theta.
Is this the one which is going to equal tan squared theta plus 1?
1 equals something.
Yeah, this one up here. Tan squared.
So I remember it. I remember that tan is sexy, that is cozy.
What was that? Sorry.
I remember it as tan is sexy and cot is cozy.
Oh yeah, you can do that as well.
Yeah.
Yeah, that's cool. Yeah. I guess like in an exam, like you obviously don't have to show all this working. But I just want to show you how like easy it is. Like it's not like the teachers didn't just grab them from the textbook and then put them in the classroom. Like they actually came from somewhere, That's why I like maths, because when you learn how to derive something, like you actually learn its significance. Anyway, so yeah, the next one we're dividing by cos squared theta. So we get sine squared theta over cos squared theta plus 1. Yeah, well, yeah, because cos squared theta over cos squared theta is 1. and then 1 over cos squared theta. So what is this simplified to become? Sine squared theta over cos squared theta?
10.
Yep, tan squared theta. Plus 1, and then this becomes?
Sec.
Yeah.
Yeah, sec 1 on cos.
Squared. And that's it. And that's the third identity. And that's pretty much it. Easy, right?
Yeah.
And then so are those the only 3 identities or are there others?
I think for now in your course, these are the only ones you need to know. But there will be others, I think. I'm pretty sure if I just look up 1 second. Actually, no, these are the only identities, but you will learn other trig laws and stuff.
Oh, okay.
Yeah. Yeah. And you also need to know the complementary identities. So you know that cos of 90 minus theta is also sine theta. Cot of 90 minus theta is tan theta, and cosec of 90 minus theta is sec theta. So these are actually from your textbook, if you recognize like the blue background. So if you do write notes for maths, I don't know how you guys do it, but I used to write like sort of notes down in a separate book just so I can remember everything. But it's good to have these down because like the day before an exam or even while you're studying for an exam, it's a good reference point, you know, like it's good. It acts as something to look back towards and to refresh your mind and stuff like that. Anyway, so those are the complementary angles. So these come in handy when you need to simplify equations or like you need to simplify something. So it's really important that you do know these ones as well.
So should we know them off our heart?
Pardon?
Should we know them off heart?
Off by heart?
Yeah, the ones you just showed us.
Yeah. So the complementary angles?
Yeah.
Yeah. So yeah, you should know them off by heart. You should recognize that when you see something like this, when you see like sine of an angle, then that can be rewritten as cos of 90 minus that angle. So like if I have something like this, if I have like if I have sine of 43, that's the same as cos of 90 minus 43. Cos of 47. So these have the same value. So if you plug this into your calculator and this into your calculator, you get the same value.
All right.
So does that mean that the complementary angle of sine 43, I think it was, is cos
47.
47.
Yeah, that's right.
Oh, okay.
And then the rest are true. So for cot and cosec and so forth. Everyone okay with that so far?
Yeah.
Yeah.
So now we're just going to work through some examples to see how you can use your trig identities. So it's important that you know them. So when you see something, you can rewrite it as that, or you can substitute in your trig identities. So the next few questions you're going to be looking at proving the left-hand side equals the right-hand side. So, you know, in an exam, you can get these kind of questions, right? And they can come in so many different forms. And they range like from so many different difficulties, right? But like, I feel like the main rule will always apply for these questions. And obviously you want to make your left-hand side look like your right-hand side. But it's also good to manipulate both sides, because once you manipulate both sides, you can work towards the answer like quickly than just working with only one side. Does that make sense? So
yeah.
I don't know if you guys have done this question before, but I'm going to give you 2 minutes. Try to sort of work out. Try and sort of work this out. So try and prove that the left-hand side equals the right-hand side. And I'll give you a hint, like look at both sides. Like don't just look at the left-hand side and then leave the right-hand side. Like try to look at the right-hand side and maybe rewrite that in a different way and see how, you know what I mean? So see how you can sort of work with both sides. So how you guys going?
Not too good.
Yeah, I don't know how to get it. I think I try to change it to cos, but I don't know what to do.
Okay. What about James?
Clueless.
So no one worked, like, did you, so like,
I
did anyone,
try to change everything to cos on the right side.
okay, yeah. So,
And I don't know.
okay, let's look at the left-hand side. Oh, you know what, let's look at the right-hand side. Let's look at the RHS. So sec is 1 over cos, cos alpha, and then it's 1 minus sine alpha. So this is basically 1 minus sine alpha over cos alpha, right? So this is what you're trying to prove for the left-hand side. So if I look at my left-hand side, so it's cos alpha over 1 plus sine alpha. So what I can see is, I can see on the right-hand side, on the denominator, first of all, there's no 1 plus sine alpha. But on the numerator, there's a 1 minus sine alpha. So that gives me a hint, and that tells me that they would have multiplied the top and the bottom by 1 minus sine alpha. Because that's the only way to get 1 minus, the reason I know that is because 1 minus sine alpha is 2 terms, right? Like, it's not 1 term. So in order to get that to the top, you would have need to multiply by that. And
so do you multiply the left-hand side?
Yeah, so I multiply the left-hand side by 1 minus sine alpha, but I've got to multiply the top and the bottom, because if I only multiply the top by 1 minus sine alpha, then I'm changing the question. But if I multiply the top and the bottom by the same thing, then it's like I'm not changing anything, right?
Yeah.
So I multiply the top and the bottom by 1 minus sine alpha, so I get cos of alpha, 1 minus sine alpha, all over 1 plus sine alpha, 1 minus sine alpha. So do you guys maybe have a clue as to what to do next?
Can you
expand the bottom? Good.
Yeah, expand the bottom.
So I will leave the top for now. You can expand the top. Like, if this sort of was the first time I'd be doing it, I would expand the top because I wouldn't know what else to do. For now, I'm going to leave it. So cos alpha, 1 minus sine alpha over. So what does the bottom become?
1.
Yeah.
And then, because it's difference, no, it's not difference of 2.
It is. It is difference of 2.
Oh, it is.
Yeah.
It's going to be 1 minus sine squared alpha.
That's it. And then, how can you now use maybe a trig identity that you know?
Because
It's the
1
cos squared plus sine squared thing.
Yeah.
Isn't it?
Yeah, equals 1. So how is this relevant to that?
The bottom equals cos.
Yeah, exactly. Cos alpha equals 1 minus sine squared alpha. Good.
Oh, so those like other rules. Oh, okay, yeah.
Yep. So I'm going to replace this with cos squared alpha. So now what does it become?
And then can you minus the cos on the top and the squared?
Yep. I can
And then you
cancel
get
them out.
1 minus sine alpha over cos alpha.
That's it. And how can I rewrite that to make it try and look like my right-hand side over here? So it looks like this right-hand side now.
Oh, well, yeah.
I'll convert it back.
Yeah. So it becomes sec of alpha, because 1 over cos is sec, times 1 minus sine alpha, which equals RHS. So that's it. That's the question.
Okay. Wait, can I just look at it again?
Yeah.
So, was there any point on converting the right side, or just done?
Yeah, I converted the right side to make it more obvious to me as to what to do.
Okay.
So like once I changed it to the fraction, because before it wasn't a fraction, right? So once I had converted it to the fraction, then I could see that, okay, the bottom has cos and the top has 1 minus sine. I need to times at least the top by 1 minus sine, which also means I have to times the bottom by the same thing. And then once I did that, I realized what to do. You don't need to convert the right hand side. But I sometimes it can give you a hint as to what to do. So if you're stuck, then maybe try convert the right hand side and then work backwards from there.
How come you didn't times cos theta instead?
times, what was that?
Yeah, at the
Times-
top. Like, you know how you chose 1 minus sine theta? Not theta, whatever it is, alpha.
Yeah. On,
And, yeah, why didn't you use times cos?
good question. I guess I still could have, hey? Let's
Isn't
have
it?
a look. I reckon I can still get the answer if I times the top and bottom by cos. So if the left-hand side is cos alpha over 1 plus sine alpha.
Yeah.
So you said times the top and bottom by cos?
Yeah.
Okay, let's
Yeah.
do that. So if I times the top by cos alpha and the bottom by cos alpha, so I get cos squared alpha at the top.
Yeah.
And I get cos alpha of 1 plus sine alpha bottom. And cos squared, you can rewrite cos squared as
Sine.
1 minus sine squared theta.
yeah. So 1 minus sine squared theta over cos alpha of 1 plus sine squared or sine alpha. And now what would you do you think?
Do you open up the brackets?
Not at the bottom because we want to.
Can't you cancel the bottom one out and then?
No.
No,
square
wait.
it?
1 minus sine squared alpha is cos squared alpha.
Yeah, but that's what we have here. So we're going backwards. So we can, but it's not going to get us anywhere. But what about factorizing the top?
How'd you do that?
Factorize out. No, you can't factorize sine.
Because
Can you factorize
you
sine?
can factorize it because it's a difference of 2 squares.
Oh yeah, because one and sine squared theta they're 2 different terms, aren't they?
Yeah. So
Oh,
I've got
okay.
1 in sine alpha.
Oh,
Right.
and it's plus and minus.
That's it. Yeah.
Oh, okay.
And then the bottom is that. And then now what can I do? I can cancel.
Yeah.
Yeah, the plus with the plus.
Ah.
And then look, I got the answer again. So I got 1 minus sine alpha over cos alpha. And then that's the same thing as sec alpha, 1 minus sine alpha.
So really, both ways works, but
Exactly,
the second way is just longer.
I don't think it's longer. I sort of think it's the same. It's sort of the same. But the second way, you just maybe had to recognize to factorize the top.
Yeah, if you didn't, then you wouldn't know what to do. Okay.
Yeah. But yeah, good.
With the second way,
Yeah.
if you go down, it said cos squared alpha equals 1 minus sine alpha or whatever it was.
Yeah, this one. Yeah.
Say that the top equal 1 minus sine squared alpha from cos squared alpha.
No.
Yeah, because of the identity. So the identity over here is cos squared alpha plus sine squared alpha equals 1. And then when I make cos squared the subject, I get 1 minus sine squared. So this is the same as this. So I can replace cos squared with 1 minus sine squared.
Okay.
Yeah, James, that's from the identity.
Yeah, that's the trig identity. Okay. Are we happy
Can we
with
do
that?
another example?
Yeah, let's do the next one.
Good.
So I like this one because it looks pretty ugly, isn't it? Doesn't it?
Yeah.
But I like it because it's honestly so easy. Like this is probably the easiest out of all the questions. Anyways, I'll give you guys 2 minutes. Try to. I'm sure you guys can get there if you do something. You got to start somewhere. So go for it.
Well, I got the bottom part, but I didn't get the top. Well, maybe I did, but I don't know what to do.
So I'll give you guys a tip. Just make sure you convert all the sines and causes and all like the tans and stuff, convert them to the most basic form. So, yeah.
That's what I did. I try to find the common denominator and stuff.
Yeah, that's right. Find the common denominator.
Wait, can I tell you where I'm up to?
Yeah.
All right, so I got I think I've done something wrong probably. I got sine y plus sine squared y plus cos squared y over cos or sine cos.
Let me see my working. What did I do? So you got
I got sine y
plus sine squared y.
plus cos squared y
Yeah. Over
cos or sine cos, same thing.
sine y cos y. Yeah.
Yeah.
Yeah. Okay.
Oh,
So
I think I just got cos y times sine.
yeah, on the bottom. Yeah. So
Yeah.
you're almost there. What's the issue?
I don't know what to do now in the
Okay.
numerator.
Try to how about you use a trig identity?
So we're gonna use you can use the whatever you call it.
Oh.
Sine squared plus cos squared equals 1. So
That's
it's gonna be
it.
sine y plus 1 equals sine y over cos y.
Yeah, that's it.
Yeah.
Good. Easy.
No, that was actually easy.
Awesome.
That was actually
So just for the sake, I'm just gonna go through the solution again. So left-hand side. So everyone got it? Brendan, did you get it?
Yeah.
Yeah. So 1 over cos y plus sine y over cos y
Plus cos.
cos y, yep, over sine y.
And then common denominator.
Yeah, common denominator. Cos y sine y.
Yeah.
So it means I multiply this one by sine y. I multiply this one also by sine y, sine squared y. And then I multiply this by cos, so I get cos squared y. And then cos squared y plus sine squared y equals 1.
1.
So it simplifies to sine y plus 1 over cos y sine y. Good.
Which equals RHS.
Yeah. Pretty easy, isn't it?
Yeah.
Yeah.
Okay, cool. Let's do this example.
So would you recommend if there's ever like cot or sec or cosec,
Yeah.
the first thing we should do is to change it to the most basic form?
Yeah, that's what I do. Yeah, because I always try to do something. Like I'm not just going to sit there and stare at it, because staring like actually doesn't get you anywhere. So if you sit and try do something and it doesn't get the answer, well then you know that's not the right solution. So try another way, you know. Okay, do you guys want to attempt this last question?
Yeah.
Yeah.
Yeah. Is this like an extension question or is this like an advanced question?
No, this is an extension. This topic is only an extension topic.
Oh.
I'm pretty sure, yeah.
No, because I'm doing it now in advanced.
Oh, you're doing it in advanced?
Yeah.
Oh, maybe it is an advanced topic. But
It
I know
is,
it's... Oh, okay, fair enough.
Yeah, it's good for me to know the harder questions anyway, because it'll make the other ones easy.
So are you doing 3 in it as well?
No, I'm doing 2 units.
Oh, okay, fair enough. Then yeah, no, this then if you do 2 unit, then you should still be able to, because like it only uses the trig identities, you know, so it's nothing different.
Okay. So I just forgot.
Yeah.
Does 2 cos squared minus 1, does that equal cosec? 2 cosec?
So 2 cos squared minus 1. No, it actually doesn't. Or as an identity?
Yeah.
No.
Like how to simplify that?
So this one, what you're going to have to do is you're going to have to use this trig identity. So sine squared plus cos squared. And then you're going to have to substitute, yes, 1 minus sine squared into cos squared.
Okay.
Oh, so this 2 is confusing me.
Yeah, I know. But you can't actually do anything with the 2. So you have to substitute something else in to cos squared, not 2 cos squared.
I'm just going to wait.
Well, do you have like cos? Did you factorize cos out of the top and sine out of the bottom? Okay, you're almost there.
Yeah.
You so maybe.
I know it equals 1. The bottom equals negative sine times 1, I think.
Yeah, maybe. Yeah, because if you sub it in, well, in the denominator, maybe substitute something into sine squared.
Oh.
So,
That doesn't do anything.
What doesn't do anything?
No, I'm smart working out.
Oh, okay. As usual.
You don't really get any of this.
Brendan, do you remember this question? We did it honestly, we've done this question 3 times with Brendan. He still doesn't know how to do it.
No, I do.
All right, then show me. How do you do it?
Sine.
Oh.
doing that.
Wait, doesn't it equal negative sine times 1, or am I like still?
What, the bottom?
Yeah.
No, but leave the cos squared. Just substitute into sine squared.
Oh, okay.
Oh, so I don't have sine squared out the front. I only got sine.
No, only sine's at the front.
Sine squared in the bracket.
I've done all of it. It still equals 1, like inside the brackets.
Oh, it equals 1. So in the bottom, on the denominator, you have this. You have sine is cos squared theta minus sine squared theta, right?
Oh, so what I did was I had a negative sign out the front, and then I put the positive in the middle.
Oh, okay. But then if you took the negative out, then the cos should be negative and the sine should be positive. Do you know what I mean? Because you're dividing negative from both terms, which means that this is initially positive, so now it's negative if you take the negative out. So that when you expand it again, it becomes positive.
Positive.
So just leave the negative in. Don't take out the negative.
Okay.
And then you said change sine squared theta.
Yeah, change the sine squared theta in the brackets.
Is going to equal 1 minus cos squared theta.
Yeah, exactly.
Which is going to give you...
So in the bottom, it's just sine side of cos squared.
Yeah.
Plus 1 minus cos squared.
Close. Yeah, close. But there's a minus here. So if sine squared, so I'll just show you. So let me just write what you guys are up to. So the top is cos theta. So you got 2 cos squared theta minus 1 over sine theta cos squared theta minus sine squared theta.
Oh, I got it.
Who was that?
Me.
Oh, finally.
Yeah, me. I got stuck.
You got stuck?
Yeah.
Okay.
Once I factorized them, I tried a few things. It didn't work.
Okay, good. So when I did this, I just straight away realized that the right hand side is just cot, and cot is like cos over sine, right? And what I have so far on my left hand side is I have cos over sine and a whole like load of other stuff. So I look at that as, okay, I need to cancel these brackets somehow. Right now I can't because they're not the same. But I know cos over sine is going to get me my cot. But I've got other stuff I have to get rid of, right? So my aim is to try and make these brackets the same. So I look at the top and I see that there's cos. I look at the bottom and there's cos and there's sine. So I'm going to try and change sine into something to do with cos. And I know that sine squared theta equals 1 minus cos squared theta. So I'm going to substitute this in to my sine over here, my sine squared. So the numerator remains the same because I'm not like changing anything. And the denominator is sine theta cos squared theta minus bracket 1 minus cos squared theta. And then the top remains the same once again. And then I just simplify the bottom. So cos squared theta, and then I multiply out the bracket, so -1.
Oh, I get it.
Yeah, I think
It's going to be 2 cos theta minus 1.
Yeah, there you go.
Oh, that's what I did wrong as well.
See, I changed it to sine. I did the other way around.
You could have changed the causes to sines, but it was easier to change one sign rather than change two cos. So it doesn't matter, but yeah. And then the bottom becomes 2 cos squared theta minus 1, and now I can cancel them and be done with it.
Oh.
Then you get cos and sine equals cos and sine, which is right hand side.
And I get cos theta over sine theta equals cot, which equals the right hand side. That's it.
You make it look so easy.
No, you know what I do? I just I try a bunch of things, and when I'm not getting anywhere, I stop and I look at what I have. I'm like, how am I not getting the answer? And what I realized is cos over sine is you're pretty much halfway to the answer, right? It's just this other stuff you have to get rid of. Or at least that's the way that I sort of looked at it. And I was like, okay, how am I going to get rid of these? I need to change sine to cos so I can try and cancel something, or, try and factorize or something like that. Yeah. I haven't done this one, so I don't know if it's easy or hard, but you guys can try and let me know. Okay, so who's gotten it so far?
So far,
I'm going all right.
After I changed tan to sine on cos, then cos tan is sine on cos and then times it by sine A.
Yeah.
Then I got cos squared. Oh, sorry, I got cos alpha minus sine squared alpha over cos alpha.
No, well, if you want to put the cos over cos, then you got to times the cos by the cos, because if you're making that common denominator, initially cos
that was my
denominator of 1.
Oh, yeah, I got
yeah.
So then my next step after that was cos squared A minus sine squared A over cos squared A plus sine squared A. Yeah,
pretty much, yeah.
And then from here, do you, would you change, sine, or would you change a cos squared alpha based on our first function?
Yeah, exactly. Because if you look at the right-hand side is in terms of sine. So I would try to eliminate the cos in your thing.
Sine.
Can we change cos A because it's not a square?
Yeah, it is.
Well, you should have gotten a square. Oh, the denominators cancel because on the top, because you know how you're going to get you're going to get a fraction over a fraction. In both of those fractions, you should have gotten a denominator of cos of A.
Yeah.
And then those actually cancel because both the fractions have the same denominator. And so they will actually cancel. And so what you're left with is the numerator over the numerator. Does that make sense or not really? Not really?
So I got this written out. I got cos squared A minus sine squared A over cos A.
Yeah.
So I don't know, how do I cancel cos A?
So that's just this part. So you must have just done the top of the initial thing. So where's the bottom part? So I'll show you. So this is what.
Yeah, I didn't do the bottom part.
Okay, yeah. So you need to do the bottom part as well.
Oh.
And then you can see that.
They're two fractions on top of each other.
Yeah, these are two fractions.
Okay. So with the top one, when you do break it down, is it 1 minus sine squared A minus sine squared A?
Yeah.
The top?
Yeah.
Yeah.
So, and that's not over cos because it cancels because of the bottom.
Yeah, exactly, yeah.
Okay.
So I write what you guys are up to. So cos A minus, and then tan is sine A over cos A. Times sine A all over cos A plus sine A over cos A times sine A. So the top simplifies to cos of A minus sine squared A cos A.
Yeah.
Over cos A plus sine squared A over cos A, right?
Yeah.
So, so I'm going to make a common denominator with the top fractions. So I'm going to put them over cos A. So this becomes cos squared because I need to times it by cos. And then this becomes minus sine squared A. And that's all over, same common denominator at the bottom. So this becomes cos squared A. And then plus squared A. And then what happens is, because of the way that you divide fractions, these cancel. Do you want me to show you why that happens?
Can you
Is
do
that,
the outer over
You have to
inner?
do the reciprocal, you times them and then you
Pretty
cancel,
much, yeah.
like when you open it up.
That's right. Yeah, they're going to cancel, yeah. Well, someone said something? Can I?
isn't it compound fractions or something?
Outer over inner, whatever it is. Like the top two.
Yeah.
The top and the bottom.
Outer times inner, yeah. Yeah, outer over inner, yeah, that's right.
Yeah.
So when I times these and I times these, I'm going to get this at the top and this at the bottom, so they're going to cancel.
Yeah.
Yep. I understand.
Yeah, and then let's just make this a bit bigger. Okay, and then so from this step here, so we have cos squared A minus sine squared A over cos squared A plus sine squared A. So what's the next step?
Change cos squared A to 1 minus sine squared A.
Yeah, so why wouldn't you change, why didn't you change the sine into cos?
Because it has to
Yeah.
equal 1 minus 2 sine, not cos.
Exactly. Yeah, because the right hand side is in terms of sine. Okay, so the identity states that cos squared A equals 1 minus sine squared A. So I'm going to substitute that into here. So I get 1 minus sine squared A minus sine squared A over 1,
Same thing.
yeah, 1 minus sine squared A plus.
But it's plus.
Yeah, sine squared A. And so at the top simplifies to 1 minus 2 sine squared A over the bottom. So these cancel. And then you're just left with 1 at the bottom. Yeah. And that's it. 1 minus 2 sine squared A, which is the right hand side.
I thought you had to factorize.
No, there's why? Look at it.
Okay.
Just that.
Okay.
So it's just over 1 and, you know.
Over sine squared alpha.
Or just A. So yeah, that's it. Do you guys have questions on that question?
No, I'm good.
No, it's all right.
Any questions in general?
So it's really just looking at like what you have on your left and your right hand side, and then when you sort of look at them as like together instead of each side separately, then you sort of know how to manipulate either side so they can equal each other.
Yeah, that's a beautiful explanation. Thanks for that.
Thanks, Brendan.
Okay.
Yeah, no, that's exactly right. So don't just look at the left side in isolation, like just also consider the right hand side to help you work through to the answer.
Yeah, because if I didn't know that we had to get sine, then I probably would have changed sine instead of cos.
Yeah. You almost would have gotten the answer and then you would have stopped being like, oh, I don't know what to do, but the answer's right in front of you.
It's really easy.
Yeah. That's it, guys. So make sure you know your identities. We didn't really use these identities much, the sec and the cosec, but they can come up in the same way that these can come up as well. So yeah, any questions?
No.
Nah.
No.
Cool.